Question 33 is a typical question about induced EMF. Okay, then it talks about what is the variation of currents of the loop in time. Remember, current equals induced EMF over R. And then the induced EMF equals negative rate of change of magnetic flux. So look at the coil. The coil is a rectangular coil. When it moves inside the magnetic field, the magnetic flux increases uniformly, so it is constant when it is moving inside. When it is moving outside from the magnetic field, also the change of magnetic flux, the decrease of magnetic flux is a constant, but now this time it's a decrease, so still a constant induced EMF, constant induced current, but opposite side to that when it is entering the magnetic field, and when it is completely inside the magnetic field, it's fully surrounded by magnetic field, so the rate of change of magnetic flux is 0, so the induced EMF, induced current is 0. So what is the answer? Constant current at first for some time, 0 current, and then negative opposite current when leaving the magnetic field. So what is the answer? You can draw it out, and that's it. The answer is C. Constant, 0, constant negative, constant opposite. Thank you.